Hello friends. Now let us take up the concept number 2, 1.2, computer organization, and this is also known as block diagram. Using block diagram we can explain the computer organization. In the previous concept I explained to you, a computer system is the composition of several components. Now, depending on the functionalities of the components, we can classify into 6 groups as units. In this context, you must remember one thing. This is regardless of the size of the computer, configuration of the computer, shape of the computer, or brand of the computer. All computers, all the components of the computer are classified into 6 groups simply depending on their functionalities. So, this block diagram is written by taking into consideration of the functionalities. So, once you study this, you can understand how different components are organized in a computer. This knowledge is a must. And in this context, one point I have to tell you, just you can have an outline idea. Don't expect everything overnight and all that. You don't require that also, because you want to become a software engineer, software programmer. For that, you need not have complete hardware knowledge and all that. If you have that, you are blessed. Suppose you want to drive a car. If you want to drive a car means you need not become a mechanic. Understand? So, in this context also, if you have some hardware knowledge, relevant knowledge, you need not require deeper knowledge, then you can understand many software concepts logically without any doubt. That is the basic objective of the interaction of this basic pool in our subject. Now, first, depending on the functionality, we can classify all the components of a computer in 6 groups: input unit, output unit, memory unit, ALU, that means arithmetic and logical unit, control unit, and secondary storage unit. Once again, I repeat that: input unit, output unit, memory unit, ALU, arithmetic and logic unit, control unit, and secondary storage unit. And by composition of all these units, then a computer system is developed. Now, first let us consider this small figure. By this, you can understand the strategy behind it. Now you see, this is input unit. Input unit is meant for giving inputs to a computer. It may be in data or it may be an instruction. Then it goes to the memory. Whatever instructions or data we give, it is stored in the memory. Okay. Thereafter, here secondary storage unit is there, or it is simply called a secondary memory. This is a temporary memory, this is a permanent memory. Now you see, temporary memory, permanent memory. On this blackboard, I am writing several things. After a few minutes, that is erased and new data I write. Understand? So this is you can treat it as a temporary memory. Okay. Whatever information you require permanently and all that, what you are doing, you are writing the data in your notebook. So that is a permanent memory. In the same way, this is a memory, what we call a memory. There are several names like a primary memory. This is primary memory, this is secondary memory. Primary memory is meant for storing and performing operations, but it is temporary. Whatever information we require and all that, that is secondary memory. In this, it is like your notebook. This is like this blackboard. Thereafter, control unit and ALU. Actually, in this context, I have to tell you one thing. In fact, these two together, called as central processing unit, or simply CPU. Now, as I told you earlier, we are focusing on the functionalities. So, ALU, arithmetic and logical unit, it is meant for performing arithmetical operations and logical operations. So, its functionality is different. Control unit, it controls the entire system by giving instructions and all that. When we are executing several programs on a computer, then without any conflict and all that, we are able to do that. All these because of this control unit controls the entire unit by passing the instructions and all that. Actually, both together we call a CPU, central processing unit. But functionality wise, control unit perform a different type of functionality and ALU perform different type of functionality. But they together should work, and that's why we in this context we are treating them as separate units. That is control unit to control the components of the entire system, ALU to perform arithmetic and logical operations and all that. Next thing is, okay, all processing is being made. We give input that is stored in the memory, and by CPU, all the operations, whatever the required operations are performed. Ultimately, you want to see the result. If you want to see the result, this is the output unit. Through the output unit, it is displayed. So, in this manner, you have to understand there are 6 categories of functions are performed by a computer system, and 6 types of units are there. If you understand that, basically you can get an outline idea about the computer system. Thereafter, this is just gives an outline idea, and this is a block diagram is more technically it is being written and all that. And here, if you have to understand one point, you have to understand there are filled straight lines, filled lines, and dotted lines. Dotted lines transmit the commands and signals and all that, and filled lines deal with the data. Already I told you, in program, two types of things are there. One is data, other one is instruction. As I told you in the previous concept, 5 plus 4 is there and all that. 5 and 4 are data items, and plus is an instruction. Here instructions are required, and computer gives the control unit gives the commands and all that, and those are represented by dotted lines. And other data transmission is done through straight lines. That you have to understand. Then if you study this diagram, actually you have material, you can download it and thoroughly study that. By that you can have a outline understanding. It never be Greek and Latin. What I meant to say, I am not discouraging you to learn hardware and all that. You learn whatever is required, you learn that much, because your main objective is to become a software programmer. That's why. But without having hardware oriented basic knowledge, you unnecessarily you get lot of doubts. And one more problem is, you always feel a computer is a magic machine. You should not have that. Being a prospective professional, you should not feel computer is a magic machine. Hmm? It is the layman's idea. So you should not have that. Once you have this outline knowledge and all that, you can understand many programming concepts in a logical manner. That is the basic objective of interaction of this block diagram, and study that. Try to understand. If you have any abstract knowledge, don't worry about that. While you are progressing, definitely you can get answers for many questions. In this context, one point I have to tell you. Whenever you get a question, and if you are serious about that, definitely you can get an answer. Getting question is the source, and one day through one source, then you get the answer, then the doubt is clarified. Especially in programming domain, all the students should have that attitude and inquisitiveness, and you get the question, definitely it is answered.